Hello everyone, welcome to this video which is going to be going through basic layout types. This is building on process design and particularly manufacturing processes, but as the name suggests, we're going to be taking a closer look at the physical layout of different processes. So if we start just by taking the basic question of what is layout design, what is the definition of layout design? Well, it's concerned with the positioning of resources, both human resources, i.e. employees and workers, as well as material resources, transformative resources such as machinery, and combined with the allocation of tasks, gives us a sense of how to organize the flow of transformed resources through a particular process. So it's concerned with obviously the physical layout within any given manufacturing or service process, but also with the movement of goods and services through the physical space itself. Now, as you can imagine, this is a very specific topic. So if you take a general process, let's say processing or manufacturing shoes, you take two different companies with two different operations. Even if they're manufacturing the same type of shoe, they could have extremely different layouts if we were to look at it on a map, based upon space available, based upon operational priorities and optimizing for different operational objectives, based upon the scale of the operation and the maximum capacity. So what we're not going to try and do is try and sketch actual physical layout maps. That's extremely unique to every given operation, but we are going to look at basic layout types. So general principles and ways of arranging our resources within an operation, and they largely can fall into particular general categories. So we have basic types, and most layouts that you examine will be variations or within these basic types. So we have four types that we're going to be concerned with, and those are fixed position, functional, cell, and product layouts. We are going to be going through these one by one, but what I would like to do first before we do that is just place this within the context of other operations management concepts. So particularly here we have process types. So what you would need to do first is establish what process types. You have to go through the process design activities, and then we can see how this aligns with and interacts with our layout design. So if we just examine first on the left, manufacturing process types, and we go through project processes, jobbing, batch, mass production, and continuous production. And these do align fairly well with our layout types, our basic layout types. So in the order of fixed position, functional, cell, and product layouts. With regards to service processes, this is a little less neat. Service processes do differ far more depending on the type of service we're dealing with, but we can largely see a roughly similar spectrum here, going from professional services being closely aligned with fixed position layouts, service shops being heavily dependent upon the exact type of service that's being offered, and then mass services tending towards cell and particularly product layouts. So this means that when we look at layout design and layout types, we have to understand that this is firmly within the general operation itself. So all of those other operations management concepts that are so important, things like the 4 V's to describe our operation, particularly variety and volume, very much have a massive impact in how we design our layout. So we have to design our layout in the context of the broader operation, in the context of the capacity of our operation, of the volume, the variety of what we're producing, as well as considering our overall operations management priorities. So what are we optimizing for? What are our performance objectives when it comes to our operation? And that's going to have a big impact on this as well. So if we go through each of these 4 layouts one by one, we'll get a better understanding of exactly what the strengths and weaknesses of each of these layouts are, and where they would be appropriate to use. So if we start with our first, so fixed position layouts, this is strongly associated with project processes when it comes to process design, and that's because they're particularly useful when we're considering the type of manufacturing process where we can't really move our finished good around. So instead of moving our transformed resource, so the resource that we're actually producing in the operation, we're actually going to move our transforming resources around the transformed resource. So we have our fixed position for the transformed resource. So that can be something like if you're manufacturing a satellite or you're manufacturing a building. We're not going to be moving the building or the satellite around from room to room or place to place. So instead, that remains in a fixed position. And our transforming resources, so that can be employees, staff, individual supplies, materials, equipment, tools, all of those are being moved around the thing which is being transformed. So it's called fixed position because the position of the actual transformed resource, the thing we're producing, remains in a single position. And that can be for a variety of reasons. So when we mention things like buildings, it's absolutely impractical and nonsensical to say we're going to move our building around. Although I do have to point out that we do have things such as prefabricated buildings and so on, but by and large it simply doesn't make sense. But even when we have much smaller resources, much smaller products, so things like a satellite, it's fairly large, but it's certainly not bigger than most rooms in production facilities. It absolutely can be moved around from place to place, but there's very little reason to do so. It is fragile, it can be damaged in transportation, and it requires the type of skill sets where we can actually benefit from arranging our transforming resources to actually come and work on the satellite individually. So even if we're not talking about large impractical things, even with smaller items, if there is a degree of highly specialized skills involved, as well as fragility or some other reason not to move our resource around too much, then a fixed position layout would be ideal. Now, there are a significant number of things to bear in mind when it comes to fixed position layouts. So it does lend itself very well to product and mix flexibility, which effectively we're talking about high variety. Because it's fixed position, that means each one that we produce can be very much customized, it can be unique. So it does have that benefit, and it does have a high variety of tasks for staff. So we're going to see in a related video on layout design as it relates to job design that this can be a beneficial impact for the management of staff and human resources within an operation. And also the product or customer isn't themselves moved around a huge amount. But the drawbacks are fairly obvious. This does result in very high unit costs. So when we have this degree of variety, so extremely high variety, we're going to see very low volume typically related to that. And that is due to high costs, but also the nature of the production itself, as well as challenges in making sure we effectively manage our scheduling. So because the item that's being produced, the transformed resource is actually fixed in one position, so everything has to be carefully managed around it. So when it comes to scheduling particular activities, scheduling equipment, as well as just scheduling space, there's a limit to how much simultaneous work can be carried out around the product, and that all presents significant scheduling challenges. So as a result of this mix of strengths and drawbacks, we do tend to see fixed position layouts for high variety, low volume work. Just a quick note on service processes. We did say that service processes can be a little looser. They don't adhere so closely to this spectrum as manufacturing processes do. But an example of a fixed position layout for services would be something perhaps even around hairdressing. So the customer is seated and work goes around, work happens around the customer. So this means that there is, things generally are the same. Scheduling can be difficult. So in this case, you only really have one hairdresser, or at the most, I guess, two if needed, working on the customer at any one time. For hairdressing itself, that's actually perfectly fine. But you can see how this doesn't necessarily chime exactly with that spectrum. Hairdressing is not a professional service. It's akin to either mass service or a service shop, depending on the type of hairdresser. So we can see that it doesn't always fit so neatly in there. However, something like a consulting service, where someone goes into an organization, observes, questions, investigates, and then produces a report with recommendations, that would be akin to a fixed position layout. So here, the staff member or the consultant themselves is actually moving around. So they have to schedule their activities, they have to be in place at the right time to observe whatever's happening within the organization that they need to observe. And then that would fit quite neatly in. That is high variety, very low volume. And in this case, the transformed resource, the thing which is being observed in order to produce the consulting report, doesn't move, it remains in one place. If we move on to our second of our four layout designs, so here we have a functional layout. So with a functional layout, we do actually have movement of the transformed resource. So the thing that we're producing, the thing we're outputting, will move from place to place. But here the movement occurs with grouped activities. It can be sequential, but it's not necessarily sequential. So in this example of a teddy bear going through a functional layout process, we see that there's four distinct groups of activities. So there's multiple activities involved in fur cutting, multiple in stuffing and sewing, and in dressing, and then finally shipping. And each of these would occur in a distinct location. So that can be a distinct room, it can be a particular part of a factory floor or a shop floor. But we're grouping those activities, and each of the groups will occur in a distinct location. So this has some significant benefits for us. It means that the skill sets that we're using can be grouped together. It means that we're benefiting from ease of assigning staff to particular skill sets. So the people who are undertaking the shipping, for example, don't have to be skilled in stuffing and sewing the teddy bears, and they can take part in all the different shipping activities. So, presumably, forming the boxes, taping them up, placing them in, whatever packaging needs to occur, and then labeling, and then moving and storing. So all of those skill sets are grouped together as well, so you can have individual employees that can work across that entire group of activities without needing to have expertise in the other group of activities. So we have clear benefits for this. But as with everything, there are downsides or drawbacks as well. So we see those benefits as easy to supervise and assign, relatively robust in terms of disruption. So if you have an issue with shipping, or you have an issue with the dressing of the teddy bears, it doesn't necessarily impact directly some of the other grouped activities, but we have other issues as well. So the flow can become complex, especially when you start having activities which are not sequentially grouped. So we have a logical movement of activities, but groups of activities may stretch across each other. So it may mean that you have group 1 occurring at the start, mostly, but then they need to go and have group 2 activities done on them and then return for some more group 1 activities. And once you get that kind of overlapping flow of activities, the flow itself can become quite complex, and there can be quite a lot of movement back and forth, which can be challenging to manage. We also have WIP, so this is work in progress. So it means that because we're grouping activities, that there will be a large number of outputs. So the transformed resources, there can be a high amount of transformed resources. So in our example, lots of teddy bears in various stages of production at any one time. And that can be, again, an operational challenge to manage, as well as low utilization. So in this case, if we have additional resources, machinery and staff, because we're grouping activities, it may mean that depending on the length and the intensity of work being done at any one group of activities, we may be underutilizing resources and staff in other groups of activities. So that again is a challenge as well, and that can be a distinctively important drawback, particularly as you move up the volume and reduce the variety. So with higher volume goods, you tend to have smaller and smaller profit margins and operating margins. So low utilization and high work in progress rates will really work against that. So we move on to cell layouts, which are our third type of layout design. And now we're moving into higher volume and consequently lower and lower variety. So cell layouts have as one of the guiding principles, we are still grouping types of activities, but now we are doing it in sequence. So rather than activities cutting across each other, so you can be moving back and forth in different groups, here we're arranging them in sequence and we're grouping them in sequence. So you'd have the transformed resource moving from one to another, but in a clear sequence which is not overlapping or reverting back to earlier groups. And the other principle we have with cell layouts is working within particular groups. So this distinctive horseshoe shape we see, or semi-oval or semicircle shape, really facilitates the use of group working. So you can have employees that can very easily move from one station to another station. So this isn't a production line that you would use in, say, continuous or mass manufacturing, where you would just have each employee responsible for a single task and remaining stationary. Here employees have the ability to easily turn around and move to another position within the cell itself. You can have assistance being given by other team members working within the same cell. You can move your team around to address particular issues at one part of the cell as the product moves through. So it has lots of flexibility when it comes to that. So there is that huge benefit of team working, and the physical layout of a cell layout reflects the creation of these groupings to facilitate and to encourage that. But it also has the other principle that we are moving sequentially through. So now we're physically moving the transformed resource from one cell to another cell through a particular sequence. So with a cell layout, we have those clear benefits: fantastic group work, resulting in strong motivation. We can have fast throughput, and particularly when it comes to work where the tasks are not evenly distributed in terms of intensity and time. So some tasks could take greater intensity, greater time, greater effort. Others could be done a lot quicker. Well, because you can quite easily move staff members back and forth, you can maintain throughput as well. So that's a significant benefit there, and it gives a good compromise between volume and variety, but you certainly can achieve higher volume than you could with the other layouts we've looked at previously. But this does require a lot of physical space. So if you were trying to arrange a layout within a factory floor to maximize space utilization, cell layouts are in some ways quite wasteful with the space. So they do require greater space and greater arrangement, and that can be fairly costly. So there are those significant drawbacks there. So we can move on to our final layout, which is a product layout, and this may be a little bit more familiar when we think about really high volume processes. So things that would use a mass production process or a continuous production process. So with a product layout, we have every activity sequenced, and we have the movement occurring purely on the part of the transformed resource. So we can think of this as the exact opposite of a fixed position layout. So in a fixed position layout, the transformed resource doesn't move at all, and instead the transforming resources move around the transformed resource. So you can have a satellite or whatever is being produced in the middle of a hall, and then the employees, the staff, the equipment, the material will all move physically around the satellite. With a product layout, if you're producing something, the item being produced will move from the start of the product layout to the end, but the actual transforming resources don't move. So the staff don't move from alongside the transforming resource. A transformed resource, the staff will stay at particular stations and carry out a singular activity on everything moving through the production line. The equipment doesn't move. The equipment stays in its allocated place as well, and does its work as the transformed resources move through it. So we have the opposite of a fixed position layout. This has massive benefits in terms of space utilization. We can really arrange the space in a way that we can fit the maximum amount of equipment and transforming resources in the minimum amount of space. We can get extremely high throughput within a product layout, and within mass and continuous production generally. You aim to have steady continuous movement through the entire production process itself, so that can allow us to achieve very even utilization and therefore very high throughput. So very high volume can be achieved. So it's almost certainly what's being used for any item of whatever industry or sector that's being produced in sufficiently high volume is almost certainly using a product layout. So the benefits are fairly clear. It will give us very low unit costs while being able to achieve high volumes. We can have very specialized equipment because the equipment doesn't move. It doesn't need to carry out different types of activities. We have highly specialized single activity equipment that's only used to carry out one unit of work on the items moving through it. However, we do have challenges and drawbacks as well. Despite the high volume, our ability to introduce variety in the process is very low. Because everything is so specialized, it cannot be easily engineered to produce different varieties of output. It tends to be a single variety of output. If there is going to be a change in variety, it usually requires a lot of setup, and therefore again resources and time being used while output is stalled or stopped. It's not very resilient to stoppages. If you have an issue in one activity, so in one part of the production line, the entire production line would have to stop because we've achieved high space utilization by having an even steady pace moving through. So if there's an issue with one activity down the line, you can't keep previous activities going. There is no space to stack up and store anything which is being produced. The entire line has to stop altogether. And when it comes to continuous production, then you're never going to be able to catch up or make up for lost output. So that itself is a major problem. And from the perspective of staffing and labor, because each person working on a product layout only has a single task, they're only responsible for a single activity, that can be repetitive and low motivation work as well. Right, so that was our four distinct layout types. Now we have mentioned this throughout, but just before we finish, I do want to just kind of reiterate again how this fits into our overall understanding of operations management. So where we have intermittent flow and intermittent work being carried out because of scheduling challenges and so on. In the fixed position layout, where the actual product doesn't move anywhere, then that's going to be extremely high variety but very low volume. As the flow, the throughput becomes more consistent, steady, and rapid, then we go towards from functional to cell to product layout, and there we see that increasing volume at the cost of variety.